guys, we are getting very close to starting our first unit, which will be motion. But before we do, there's one last tool of science that we need to discuss and learn how to use. When I talk about motion, I often start with my classes asking them to draw me a picture of something in motion. And inevitably, there's two ways that I normally get it. And I'm just going to use like a bouncing ball to show, because I can't draw cars or anything. So two ways I can get motion. One way is to show these little lines showing, okay, the ball was here, then it bounced, now it's over here. So the little lines showing the path is one way that people often show motion. Another way is those ever popular swoosh lines, those little swooshes showing that it's moving through the air. But physicists, as you can tell, are not artists. And if we want to depict motion, instead of trying to get the shading right and show action and maybe the wake behind a boat or whatever it may be, instead of all that, this is how scientists show that something has moved. It's an arrow. That's it. And this is a very powerful arrow. It not only shows us how much motion has occurred, but also in what direction. This arrow is called a vector. Okay, so a vector tells us two things. One, how much motion, velocity, momentum, whatever it may be, tells us a quantity of a measurement, but it also tells us a direction. So our vector, we could go south a little ways, could go west a long way, we could be going very fast, we could be going very slow. Vectors tell us an amount and a direction of a measurement, okay? And we'll use vectors, we'll use vectors not only for motion, but we'll also use them for momentum. How much momentum an object has an amount, but it also has a direction that momentum is going. We'll use it for forces, how much push or how much pull, in which direction are you pushing or pulling. And so we'll use vectors for several things in physics, which is why I'm throwing it in this tools of science section instead of starting off with motion. The most important thing to remember, though, is things don't only move once. There's not only one force. There's not only one object with momentum. So we often have many vectors. We have lots of measurements going in many different directions. And so when we have that happen, then we need to be able to combine those vector measurements. Now, this is real simple if they're going the same direction. So if we say go to the store 3 miles, and then we go another 4 miles to the post office, how far are we from home? If this is our home, and here's where we are now, well, we are 3 plus 4, 7 miles away from home. So if vectors are going in the same direction, we add them together. What if our vectors are going in the opposite direction? If we went 3 to the right, but then 4 to the left, where are we now? Well, we are 1 to the left of where we started. 4 minus 3 gives us 1. We've passed that 3 and gone 1 more than we were before. Okay, so opposite directions, they cancel out, you subtract. Okay, what if, here's our little house, what if we decide to go north and then we turn and go to the east? How far are we away from home now? There's our home. Here we are now. How do we decide where we are? Well, if you'll notice, we have drawn ourselves a triangle. So think, how do I figure out this long side of the triangle? This is where lovely Pythagorean theorem comes in. A squared plus b squared equals c squared. So that's how you would find this vector side here. How far are you from home? All right, Now, you can add as many vectors as you want. You could go, say, 3, and then down 1, and then over 3 more, and then down 6, and then over 2. Same thing applies. But in this case, instead of having to get a protractor and ruler and all that good stuff, probably the easiest thing to do would be to combine the like vectors. Well, we went over and then we went over again. 3 plus 3 is 6 to the east. We went up and then we went down. Those are separate. So 2 north, 6 south. We went 2 to the west. If we take those that are going opposite directions, north and south are opposites, we ended up 4 south of where we started. East and west are opposite directions. We ended up 4 east of where we started if we cancel those out. Now we have a triangle that we can work with. We've created this triangle right here, okay? So you can add as many vectors as you want. All you need to do is boil them down to their components, east, west, north, south. May even use the coordinate plane, 0, 90, 180, 270. But combine all the things that are the same, subtract the things that are opposite, and end up with that triangle that you can use your Pythagorean theorem on. Okay? If they're at a weird, not 90-degree angle, so let's say we have, here's our house, and we have gone northeast, we'll say 25 degrees northeast, and we've done that for 4 miles. Okay, how do we figure that out? That's at a weird angle. I don't know how to do weird angles, or maybe I know how, I just don't want to because that's terrible. Well, break it down into how much north and how much east. Do you remember how to do that? Trig. You're going to use your trigonometry. We've got an opposite side, so you can use sine. We've got an adjacent side, so you can use cosine. Find out what those components are, and then you have it broken down into a north component and a south component, okay? Or east, north and east, sorry. Okay, so that's a little bit about vector addition, subtraction, combination. It is really using your geometry skills to break down our triangles into really easy things to work with, where you can just add, subtract, then do your Pythagorean theorem. Today you're going to do an activity, and the activity is going to involve a treasure hunt. Now, in our treasure hunt, I'm going to send this paper to you. It has a big, long story about how Grandma was kind of crazy and buried all of her money in her backyard. Okay, so you're going to have to find Grandma's money. You're going to use some vectors, and I'm going to send you the list of measurements so you can make your own. We have, in class, we're using just cut out pieces of paper. So just grab a piece of paper and a ruler and cut out some little sticks. In the story, it talks about using sticks, but we are just using pieces of paper. So it's going to ask you to try to find Grandma's treasure based off of the vectors that she left you. Now, she gave you an amount, a length of the stick, which translates into how many paces across her backyard, and she gave you a direction with each of the sticks, but she didn't tell you what order they go in. So you're going to try it in a couple of ways. Try laying your pieces of paper out in any order. See where you wind up. Okay, it's going to be kind of tricky moving around pieces of paper, so you might want to use some tape to like tape down your starting point, the old oak tree, tape down the ending point, measure to see how far you are. Then I want you to shuffle them up and try again. Okay, put the sticks out in a different order and see if you get something different this time. Do you end up, across the yard from where you started? Do you end up in like roughly the same place? Is it exactly opposite? Where do you end up? Then on the back, it's going to ask you to do it mathematically. Actually take your measurements and your directions, just like we were talking about. All the ones that are north combine together. All the ones that are south combine together. Take your north and subtract your south so that you can see how far north or south of the oak tree you ended up. And see if mathematically you end up in same place, very different place, exactly opposite place. See what happens. Can you find grandma's treasure without knowing the order that she left her sticks in? Okay. It's kind of a crazy activity, even for the ones that are sitting here in class with me. So if you have questions, please, please, please let me know. I'm hoping that I explained it well, but if I didn't, I understand. So just email me and I will help you out. So that was a very quick intro to vectors. The rest of the time today, if you have time left over during your physics hour, use it to go over the resources I put in the unit guide and study and refresh yourself for the test that we're going to have on Thursday. And I'll be sending you a link to that assignment, which is your test, on Thursday morning. Okay? Take care. Let me know if you need anything.